So we are talking about dealing with errors in this section. And there are different types of errors that we are going to talk about. One of them is a random error, where here we have a picture of a baby on the scale and he's moving about. So that's going to cause him random error because it's going to change the numbers by how he's on there, right? This one is a systematic error, and it's a systematic error because this should be at 0, right? There's nothing in there weighing, so the weight should be at 0, but it's not. It's at 1.2. So through all the measurements that day, if you're using this scale, they're all going to be off by 1.2, so it's systematic. All right, so let's go look at some more definitions. So that random error, again, is random and unpredictable event in the measurement process. Systematic errors, it's a problem in the measurement system that affects all measurements in the same way. There's an absolute error. It describes how far measured value lies from the true value. So the absolute error equals the measured value minus the true value. Then there'll be the relative error. It compares the size of absolute error to the true value. And so it's going to have a ratio. Sorry, the fridge in my office is getting a little too loud. I didn't want it to come through on the video. Sorry about that. So a relative error compares that size of the absolute to the true. So it's the absolute error over the true value. And then you're going to times it by 100%. So it's going to move the decimal place. Accuracy is how close the measurement is to the true value. And then precision is the amount of detail in a measurement. All right, so let's go look at example 1. So for example 1, we have the government claims that a program costs $99. Or sorry, not $99, $99.0 billion. But an audit shows that the true cost is $100 billion. Find the absolute and relative error. All right, so we're looking at example 1. So first off, the absolute error is going to be equal to the claimed value minus the true value. So the claimed value of the program was $99.0 billion, but the actual cost was $100.0 billion. Well, 99 minus 100 will get us a negative $1.0 billion. Okay? Now for the relative error, lost my pen, there it is. So for the relative error, this will be that absolute error that we just found divided by the true value, and then we'll multiply it by 100% to get it off of a decimal, and we'll have a percentage of how off it is. All right, so our absolute error we just found is negative 1.0 billion, and we're going to divide that by the true value of 100.0 billion. And let's be clear about this. These need to be in the same increment. Otherwise, that can make it a little bit difficult. And then we'll multiply that by 100 to get a percent, and that'll become negative 1%. And you can just multiply in the calculator by 100. So this is our absolute error. This is the relative error. So relatively speaking, it was 1% off. So even though it's a whole billion off, it's still just 1% of the total cost. So that's where it's relative versus the absolute. The absolute in this case sounds worse than the relative error. All right, example 2. We're back to our bell peppers. So the bell peppers are harvested and weighed in a bowl so they don't fall off the scale. We have some weights of 50 grams, 47 grams, 38 grams, 48 grams, and 500 grams. Are there any random or systematic errors? Find the absolute and relative error of the 500 grams pepper. All right, so what do we think happened in this case? So brought in my bell peppers, and got some visuals here. I brought in my bell peppers. I put them in a bowl because I didn't want them rolling off of the scale. Let's see this. They're a little bit bigger than I thought. All right, so I've got my scale. If I just put the bell peppers on the scale, my worry is that they're going to fall off the scale. They're going to roll on the floor, and then they're going to get squished or dented. Or I might have a whole bunch of bell peppers, and I want to do like a whole group of bell peppers, and they're going to start rolling off the top, right? Or they just might kind of tip over, and they're a little rounded. So what I decided to do, so I didn't have to worry about that, is to put them in a bowl. Now, when I measured them, I had some that sound about the same, and I have one that's 500 grams. What does that 500 grams seem to indicate? Well, if I hear you, if you're thinking, that's going to be a human error, right? Maybe they meant to write 50 grams and not 500 grams. So maybe they were writing 50.0, they left off the decimal point. So that's going to be a random error. But what else is happening here? So what's the difference between I measure my peppers on my scale and get a weight, and I measure my peppers on a bowl on the scale and get the weight? What is the difference that's happening here between the bowl of peppers and the peppers? What is changing the weight? Because when I do that, they don't weigh the same amount. Why don't they weigh the same with the bowl? And I get that there's 4 there. Let me pull this one. This one has 4. So it's not about the number. Okay, we've got 4 of each. And yes, this seems a little bit bigger, but it was just for scaling on here. So if I put them on for the bowl, so it's not about the size at this point of the pictures, because it's just what we've got, versus setting them on the scale. What is the difference between there? So if I'm thinking what you're thinking, there's the weight of the bowl, isn't there? So when I just weigh the peppers, I get a true weight of what the pepper weighs. But when I put the peppers in a bowl, I've now added this weight of a bowl. The bowl becomes a systematic error because it happens repeatedly on all of the weights that I use the bowl for. Okay, so for our bell peppers, bring this back down. So this will be example 2. Just a little so I have room to write. So example 2, we're talking about the bell peppers. And there are 2 errors that occur because we were asked to find, are there any random or systematic errors? So the random error is the 500 grams, right? That is a random error. We know that can't be the case. And we are going to state that this is a human error, right? Just to be clear. It's random happen because maybe they meant to put 50.0 and left off the decimal. Because a 500 gram bell pepper is going to be way bigger than a 50 gram pepper. All right, then the other one is a systematic error. And with the systematic error, that is the bowl that we used, right? We used a bowl to do that. So it's the bowl weight that changes that. Because it's going to be included in all of them. So we might have to subtract out the weight of the bowl on each weight. Okay? Now we're going to look at finding the absolute and the relative error. So for our absolute, and we're not doing it for all of them, we're only doing it for the 500 gram one. So our absolute error is going to be our measured value minus our true value. So the measured value for this one was 500 grams, right? 500 minus what we think the true value should have been 50. 50 makes more sense. It goes with the rest of those measurements of 47, 48, 38. We had another 50. So that's going to be a difference of 450 grams. Now this one is not negative. The last one was negative because the measured value or claimed value was not bigger than the true value. But this one, our measured value, was bigger than the true value, and that's why that's positive. All right, so let's go find our relative error. So again, our relative error is going to be the absolute error divided by the true value, and then times 100%. All right, so our absolute error was 450 divided by the true value of 50 will get us a 9 times 100% gets us 900%. Holy shnikes, that's a big percentage, right? So, this case here, we had several things that were going on. So you have to always really look at what is happening with the measurements, what's happening with the whole process. All right, let's go look at example 3. Random or systematic errors. An IRS agent reviews tax returns to identify the following: mistakes made in calculations and incorrect entries that were intentionally made to lower the tax bill. Is each problem a random or systematic error? All right. So, example 3. So, in this case, there were some mistakes in the calculation. Mistakes in the calculation that's going to be random. Nowadays, we tend to use like something like TurboTax or online services, but back in the day, we did everything just on paper. So you could have human error with the mistake in the calculation, right? We added it wrong or multiplied it wrong or whatever. That's going to be a random error. However, the dishonesty, which is where it said they intentionally made, there were entries that were intentionally made to lower the tax bill. So the incorrect ones, that's just dishonesty. And this is going to be a systematic error. That is not a random thing. That is something that you're doing that's causing the thing. And there may be more than one, so it's going to be a systematic. All right. And then number 4, does this make sense? I used a meter stick to measure my bed to the nearest micrometer. I used a meter stick to measure my bed to the nearest micrometer. All right, so a meter stick is like a yardstick, right? It's got a yardstick has 3 feet on it, 36 inches, and a meter stick, I believe it has 100 centimeters. So, would we use that to do a micrometer? I'm thinking a micrometer is probably smaller than a millimeter because we have meters, what is it? decimeters, decameters, decimeters, I think, and then centimeters and millimeters. So micrometers probably even smaller than that. So, does it make sense to use that? It does not. So, if we're looking for micrometers, which are small, you don't want to use a meter stick. It's not going to be very precise. So, a meter stick won't have the measurements of micrometers. Okay, it might have centimeters on it, but it's not going to have micrometers because those are really small. So it doesn't make sense to use that. So make sure you're working on your homework.